This question is from the 2024 Leaving Cert DCG higher level paper, and it's question B2. The image on the right shows a salad packaging box. The salad box includes a series of planar surfaces and a clear plastic window as shown. Figure B2 below shows the development of a similar salad box, including the clear window, which is in the shape of an ellipse. Part A, draw the given surface development of the salad box without the elliptical window. Part B, or S, okay, we're given it there, or S is the major axis of the elliptical window, P is a point on the curve, determine the length of the minor axis and draw the ellipse, or draw the curve. And part C, on a separate drawing, draw the orthographic projections as followed of the salad box when the box has been assembled. Part 1, an elevation in the direction of the arrow, and part 2, a plan projected from the elevation, including all hidden detail. Where scale 1 is to 1, so it is a little bit easier, we don't need to scale anything down. So I'll start off with the square there at the top and work my way down from that. Okay, full distance, let me see, I'm going to need 42 from the edge. I'm going to leave room for my orthographic views as well. So let's say about 60 there. Yeah, that should be loads. 110 then. Yeah. Okay, distance down from the top is 80. I'm going to keep it quite high up on the page. 80, I'll come down to about 90. Now, 110 is the full width. And height is 80. Okay, that's the top rectangle. Then we're going to work our way down. That's going to be a hidden detail line. Now, some of that will be hidden by the ellipse, so maybe I'll not just draw it in yet. We've two angles, say 42 millimeters down. Draw a light construction line there. Distance in is 15. So I'm going to measure in 15 from that side and 15 from that one and draw down two light construction lines. And that gives me the angle of those two lines then. That'll be a hidden detail line there for the base. Distance down for the base then is 50. Okay, distance down at the bottom then is 42. I'll draw a light construction line to begin with, and it'll be the exact same as the top, so I can bring down that line there. And then for the two side pieces, distance out, this is 80 is the full width. And distance out will be the same, so it'll be your 15s. That distance there for that is going to match up with the distance on the top. That's going to give me that point. should be 80. I can draw that back in. Okay, relatively straightforward. That'll be a hidden or a dash line as well for a folded line, but I'll not put it in yet because we're going to do the ellipse over in part B. Part B, RS is the major axis of the elliptical window. So we need to find it first of all now. So up 20, draw a light construction line across, and the full width is 90. So I'm going to get the center point to draw the axis, 55. And if the full width is 90, I'm going to go at 45 on each side. Okay, that gives me points R and S. Now, P is a point on the curve. Where is P? So 35 across on that dash line. Okay, so that point now is on the curve. Determine the length of the minor axis and draw the curve. Okay, so I can draw the major axis to begin with. Center point out to R, or S. Should run through the two of them. Okay, so that's my major circle. Then we go back and use the same method as we normally would when finding a point on the ellipse with the major and minor. So from P, in this case, we go down to the major to get that point. And then if we draw a line back to the center from that point and go straight across from P, that gives me a point now that has to be on the minor axis. So using that point then, we can draw in the minor circle. Okay, once we have the major and the minor, we use our usual method then for drawing an ellipse. So split it up with your 30-60 set square into 12 equal sectors. And then use the same method from each one. So it's going to touch that point, or an S. And from each one of these now we go down and up from the bottom, down from the top, up from the bottom. And then across from the minor. And each one of those points now is a point on the ellipse. And it should just run through P as well as I'm going around. Okay, so that's the ellipse finished now on the development. That's part B of the question complete. Part C now, on a separate diagram. Oh, sorry, I'll go back and put in my dash lines then. So they'll be dashed on the outside. On a separate diagram. No, and I suppose technically if it's see-through, it would be folded as well. It's not open. It's a plastic film, so it would be dashed. On a separate diagram, draw the orthographic projections as follows of the solid box when the box has been assembled. An elevation in the direction of the arrow and a plan projected from the elevation. Include all hidden detail. Okay, over on the right hand side, plenty of space here now for these two. I'll keep my XY line right there Front elevation to begin with. Now, full height, well, full width I know. I can take the full width from the development, 110. That's for the top of the box. And then it slopes in as it goes down. So how do we actually figure out the height of this is next. Oh well, we have this small one. Actually, it's a little bit easier than I thought. We have the small one down here, which is 80. So if it's 80, if I get a center point here on this, 55, the bottom has to be 80, so I need to go out 40 on each side. So that gives me the base. And then to get the top point here, looking in a front elevation, that there would be the true length of it. Not the slope line. The slope line would be too long because it's not on the vertical plane. Pick up a line that's on the vertical plane. So set your compass from there to the top, which is that distance. Bring it over to that point and mark it up there on the side. That gives me the length of the side, and then I can draw in the full front elevation. Okay, I'll not do the ellipse part yet. I'll worry about that in a second. I'll do the plan view first. I'll leave a gap of about 10 mil there to plan. Be a heavy line across. Full distance down would be the size of the top there, which is 80. That'll be a heavy line the whole way around. And then the inner lines, dash lines, I can bring these down as light construction. And it'll be the same distance in the whole way around. So that distance there is 15. So it'll be 15 from the top, 15 from the bottom. And then corner ones, fold lines as well. Or not fold lines, they're folded but they'll be dash lines because they're hidden detail in plan. Okay, that's the basic shape now, front elevation and plan view finished. We've just the ellipse now to worry about at the end. So in plan view, we can draw the majority of the ellipse there. We're going to see it as true shape because we're looking down at the top. So it's the exact same ellipse. I can bring it down. The axis was 20 from the front edge. So I'll go 20 from here. So major circle will be the same. Minor circle. Same thing again, split it up 30, 60 cents square. Now you could transfer heights and widths down if you find that easier. It's up to you, whatever way you think would be fastest. To go one more as well, just for accuracy. need to draw as far as the line. I don't need to go past it. Okay, so that's the ellipse in plan. Now it's a little bit on the bottom there that's hidden. I'm going to draw it up here first of all. So there's a couple of different methods I can use for this. I'm going to measure on the true length line. So this is the line going up the side here. So in reality, that's this line here because it matches up with this one. They're both the same height. So if I bring my heights across to that line, so for those 2 points, I'm going to bring it across and bring that one across as well. Now, I can mark those up on this line here because that's an edge view of that. Let me think now, that's edge, no, that's the full length, so I'm going to use this one here instead. So if I mark from this point up, that length there should be the full height of that, yes. That there now. So mark up from this point to that one, bring that over and mark it on the angled line here. So it's going to look a little bit shorter than what it does in the development. Same with that one, mark it up. If I bring those 2 lines across now, I can get my widths, the true widths, they don't change. Oh, I need to draw the lines there first. True width then, I'm going to go from the center point out to that point there. Sorry, that's quite dark. Center point out to that point, both are the same on both sides, and bring it over here. So that's 2 points in the ellipse. The bottom point is just in the center, and then the one above it, I can go from there to there, and bring that over to here. Okay, so that's the ellipse line now in front elevation where it's on that angled surface. Okay, so that's front elevation finished. We need to find that now in plan. It's going to dip down on the angled surface here. So we have our lines already brought across. I can drop those now straight down to the angled line in plan. Bring them straight across. Now they're very close to each other there. But those 2 should match up with that one, yeah, and that one. And then these ones go to the next one, which is there, and there. And the last one then is the center one, it goes to there. So it's a very shallow curve there because it's almost a vertical surface. Okay, so that's your curve in plan view. Now, technically, if that is see-through glass, we're going to see those lines on the bottom for the cardboard. And then it'll be hidden detail from there on in. Okay, that's your full front elevation and plan, including hidden detail, and that's your question finished.